Okay, before you do this next slide, this is the slide that you're going to have to do next. I wanted to remind you how to read these symbols and what they mean. These symbols are not any different just because we're dealing with this seemingly new exponential equation with the base of e right here. It's not any different. The transformations are going to be exactly the same as they were with any of the other exponentials, just like there were with any the absolute value or the quadratic. The parameters, the things that we look at to cause the transformations, are the A that we see right here, this A, this C, and this D. Those are going to be the parameters that are going to cause the transformations. And when you look down here, you see that A is being used several times. Okay, all three of these are talking about A. So you have to understand that this is talking about A, three different things about A. So the two things that we are worried about is the sign of A, and of course the sign of A is either going to be a positive number or it's going to be a negative number. Okay, so if it's a positive number, we don't mention it because a positive number means that it's going to behave like this, just like all the other exponential functions start off being. But if it's a negative number, and the way we say negative is A is less than 0, that's how we say negative. If it's a negative number, then we know that that causes a reflection over the x axis. Okay, so we know that it's going to cause it to flip down, and I will demonstrate that. Well, I can demonstrate it now. So when when A becomes a negative number, you see it started off up here, but now that I've made A to be 2.9, it's caused it to flip down. So this is how when we say A is less than 0, that notation, A is less than 0, is the notation that I'm using to say, hey, if A is negative, I'm reflecting over the x-axis. Okay, the other two things that we worry about is what is the value of A? In other words, is A, and the two values right here, and when we're looking at the value, we're ignoring the sign. And the way I tell you to ignore the sign is I use those absolute value bars. And so when you see that, like you see right here, the absolute value of A, don't say to yourself, don't read it the absolute value of A. Say, ignore the sign, but the value of A is bigger than 1. If the value of A is bigger than 1, then that means you're going to have a vertical stretch. And all that means is that your exponential equation, let me put A back to 1. When it's 1, that's the parent, that's considered the parent function. Okay, those two match. But as A gets bigger than 1, it gets taller. Okay, yes, you've already learned that it changes the y-intercept, and that is exactly what you can look at, is to pay attention where the y-intercept is, but that's causing it to get a vertical stretch. We're stretching it taller. Okay, the next thing that A can be, the value of A, not the sign of A, but the value of A, it can be a fraction. Okay, and this says right here, this is a fraction. When it says, the absolute value says ignore the sign, but is the value of A a number between 0 and 1? Well, what kind of numbers are between 0 and 1? Fractions. And not just any fractions, but proper fractions. Okay, so when you see the notation that has something, in this case it has A, but being between 0 and 1, they're talking about a fraction. So when A is a fraction, you're going to have a vertical compression. Okay, and a vertical compression might also be called a vertical shrink. Okay. So when you jump over here and you watch, here's where A is 1. Okay, there's A is 1. And as I make it look at decimals, there's 0.9, there's 0.8. See, I'm making it shorter. It's getting closer to its own asymptote. Okay, so that's what happens when A is a decimal. And it doesn't matter whether it's a positive A or a negative A, it's those compressions and stretches still happen. See, here's where A is -1, and if I'm a decimal, I'm closer to that x-axis. I'm vertically shrinking, but if I'm a number bigger than 1, I'm stretching. Okay, so that's why it doesn't matter whether it's we don't pay attention to the sign when we look at the value of A. The other two should be pretty easy to remember because they still are causing translations. This is shifting or translating left and right. And this is shifting or translating up and down. Okay, so how do we know when it goes up? And how do we know when it goes down? It goes up when D is positive. This is a shift up. This is a shift down. When C is negative, it's a shift left. Now, I am going to remind you, and when it's positive, it's a shift right. But remember, this is the value of C. What you're going to see in that problem is an X, because if the problem has a minus sign, the formula has a minus sign, so when C is negative, you're going to see the X plus C. This is what you're going to see. Okay, when the C is positive, that means you plugged in on top of the formula a positive number. So what you're going to see right here, what you're going to see up there is a negative C, but that really means it has a positive C value, so it's going to go to the right. I hope this helps remind you of what the parameters, which transformations are caused by what parameters, and what these notations mean.